B5. So B5 is a problem that goes through, essentially trying to figure out what element you have based off of a bunch of criteria. So in this case right here, what I'm asking is, you have an ion, it has a 5 plus charge. And so, in terms of the configuration, we know that, the n equals 1 level, right, has 2 electrons. In the case of the n equals 2 level, right, that has 8 electrons. And then for the n equals 3 level, we have 10 electrons in this case. Right, so we have that right there. And so what we can start doing is thinking about, the atomic number. So we know that we already have a total of, how many electrons is this? 20 electrons available. It has an overall 5 plus charge, right? So we're missing 5 electrons. And so that tells us then that, right, the neutral atom should have 25 electrons. And so because we know that the number of electrons in the neutral atom is going to be equal to the number of protons in the neutral atom, and then, right, the number of protons is equal to the atomic number, that tells us, right, that the atomic number of the element that we're looking at is 25, right, which is manganese, in that case. Excuse me. Right, and so that's the process there, right, is you can just add up all the electrons, and we know we have a 5 plus charge, right, and so we have to do there. It doesn't matter where the electrons reside, right, in that case, right, however many are in the n equals 1, 2, or 3 levels, right, for figuring out the atomic number, all we have to do is just simply add up how many electrons we have in total, or we're supposed to have for the neutral atom. And so now the next question is, right, the total number of s electrons that we have. And so going through, right, we know then that the configuration for n equals 1, right, those are all going to be s electrons. So we have 1s2 in this case, right. For n equals 2 level, we have 8 electrons, so that we know that's going to be 2s2 p6 in that case. And then for the n equals 3 level, right, we have 10 electrons in this scenario. So that tells us, right, we should have 3s2, 3p6, and then 3d2, right, because they all get filled up, in that order and everything. So right, so we should have 3d2, right. And the thing right here up top, right, don't forget to read that hint, right, where it says in forming ions the 4s electrons are lost before the 3d electrons. That's why there aren't any 4, n equals 4 level electrons in this case right here, because those were removed, as well as the other 3d electrons, right, that we would have expected. But now, right, to answer B, right, so number of s electrons, all we have to do is just simply add them up, right, so there's 6 of them in that case, right, because we have the 1s2, 2s2, 3s2. In the case of the number of p electrons, right, we have the 2p6 and the 3p6, right, so that's the total number of 12 electrons that we have in that case. And then the total number of d electrons, right, we only have the 3d2, so that's only 2 electrons that we have there. Atomic mass of the element, you just have to look that up, right, that should be on your periodic table. So you can just have that, right, so 51.996 atomic mass units. And so then, the question is then what's the ground state electronic configuration of the neutral atom, right? So all we have to do is just then now do, the electronic configuration for manganese. And so that would be, just simply argon, as the base, right? 4s2, 3d5, right? And that's how you approach B5, right? Is first going through, you can figure out what the element is, and then making sure, that you're writing everything out the way that it should be.